Okay, today we're going to do experiment 6, which is molar mass of a gas. We are going to take marble chips, which is calcium carbonate, and we're going to react that with hydrochloric acid, and that is going to produce calcium chloride, CO2 gas, and water. Alright, so the gas that we are calculating molar mass of is CO2. Of course, we know the correct answer. We just look at the periodic table and we will have the correct answer for CO2. We are going to do this experiment to see how close we can get to the correct answer. Alright, so we're going to be doing the molar mass of a gas. We're going to use the gas laws. PV is equal to nRT, the ideal gas law. Alright, we're going to do a substitution. To find moles, you take the mass and divide by the molar mass. So when we substitute mass over molar mass in for PV is equal to nRT, we get this equation. And then we solve for molar mass by multiplying both sides by molar mass and dividing both sides by PV. And we have that the molar mass is equal to the mass times the gas constant R times the temperature in Kelvin over the pressure in atmospheres, volume in liters, because we are using the constant 0.08206 liter atmosphere per mole Kelvin. All right. So in order to find the mass of CO2, all right, so that is the mass that we're looking for. That is going to be the mass of your flask with carbon dioxide. We're going to do the reaction. We're going to fill our flask with carbon dioxide. We have to subtract the mass of the flask with air, but that would be too much air. Air is a gas, CO2 is a gas. And so what we have to do, and that's why we have a parentheses here, is we then take our mass of flask with air, we have to subtract the mass of the air from that in order to get the flask that is evacuated, nothing in it. All right, we have to do this when we are weighing two gases. If we're weighing a liquid and a gas, the amount of gas in there is insignificant to the mass of the liquid. But when we are getting one gas, mass of a gas, we have to then subtract out the mass of another gas, which in this case is air. And so anytime you are weighing a flask, that flask contains air. All right, it is not evacuated. We need an evacuated flask for this calculation. Your volume of your CO2 is going to be the volume of your container. All right, now the pressure. All right, I have written out the pressure of the day. The pressure is 29.75 inches of mercury, which you will have to convert inches to centimeters, centimeters to millimeters, and millimeters of mercury to atmospheres. Your temperature today in this lab is 19.0 degrees Celsius, which you will have to convert to Kelvin. The density of air in grams per liter is 1.234. So again, the units for density of air, grams per liter. And density of water is 998.43 kilograms per meter cubed, the SI unit for density, which you will have to convert into grams per milliliter. And again, we know that the density of water will be very close to 1 gram per milliliter. All right, so the volume of the container that we are going to collect our gases in, that is going to be your volume of water, that's going to be your volume of air, that's going to be your volume of CO2. That is the volume that we are going to use. If we want to find our mass of water, we simply take our density of water and our volume of water, which is our volume of container, and we can solve for the mass of water. All right, if we want the mass of air, we have given the density of air, we know the volume of air. All right, and so we are actually going to find the volume from the density of water. So we know the density of water is given, the mass of water, we're going to weigh it. We're going to have the mass of water. We're going to find our volume of water. Again, once you find the volume of water, that is equal to the volume of air. That is equal to the volume of CO2. That is the volume of the container. All right, and so in order to find our mass of air, now that we know the volume of air and above we have the density of air, we will then have our mass of air, which we can subtract from our flask that has air. We subtract out the mass of air. And then we will have the mass of the flask, and then we will have our massive flask with CO2, and then do the subtraction to get your mass of CO2. All right, and so that is how we're going to calculate the molar mass of this gas. All right, and here is the apparatus set up. All right, so in our 250 Erlenmeyer flask, I have put water with marble chips. Marble chips is calcium carbonate. And next to that, I have my bottle of hydrochloric acid, 6 molar hydrochloric acid. And when I pour the hydrochloric acid in through this thistle tube, which is a long neck funnel, then it will react with the calcium carbonate as marble chips. And we have the glass tube that goes into the liquid. So when it produces the gas is going to go through this tube and through the drying tube. All right, so we have anhydrous calcium chloride in here. So we have liquid water. We are generating CO2. The reaction is exothermic. Water is a product. So we're going to have a lot of water vapor coming up through here as well. This is going to take out all of the water vapor. So the only thing coming out this end is going to be dry CO2. Dry meaning doesn't contain any water. So the dry CO2 is going to come in to our collection flask, which is our 125 ml flask, and we are going to fill that up. All right, I have weighed the flask with the stopper and the glass tube, and of course it is currently filled with air. The mass of that was 69.1536 grams. All right, and now we are ready to start the experiment. All right, so I will put this down and I will start adding some hydrochloric acid to get the reaction to produce CO2. All right, so as soon as I pour in my hydrochloric acid through the thistle tube, immediately I see bubbles. The reaction is going and it is creating CO2. And if I want to know if the CO2 is coming through on this side, I'm going to pinch here. And when I pinch here, I should have liquid going up, because as the pressure is going to build up, the liquid will go up. All right, so that might have been loose there. All right, so now the liquid's going up. So I had a loose connection here, and I would only know that by pinching this. And since the pressure didn't increase and then push the liquid up this tube, I knew that there was a leak over here. And so now I have fixed the leak. When I push this, I see the liquid going up the tube. All right, and so I know that the flow of CO2 is coming into this flask. All right, and I'm going to let this go for a few minutes. I need to fill this flask with CO2. Now CO2 is heavier than air, and so as my CO2 comes in, I want it to go all the way to the bottom, and the CO2 is going to stay at the bottom, and it's going to push the air out. This is a loose connection. If I tighten this connection, then I see that the pressure is building up. There's nowhere for it to go. And so this is a loose connection so that the CO2 is coming in, and it's staying at the bottom, and it's filling from the bottom to the top and pushing air out the top. I'm going to add more HCl. I got to keep this reaction going. All right, so we want to make sure that again it's coming all the way through. There's no leaks on the other side. I pinch, it goes up very rapidly because I have just added HCl and we are generating a lot of CO2 at this point. Lots of bubbles over there generating our CO2. All right, and so I'm going to make sure that my flask is completely full of CO2. I'm generating a lot of CO2. Of course, the first coming through, the CO2 is coming through, but at first this is all air, this is all full of air, this is full of air, this is full of air. All right, so the first amount of CO2 that might be coming through is still just air. So it's going to take a while for that to be all CO2 at this point. It is definitely all CO2, but it is an invisible gas. You cannot see the CO2. All right, again, we got plenty of CO2 coming over. And when you pinch this and that goes up that rapidly, you know what volume that is coming over here. It is a pretty good volume of CO2 that is being produced. And it is definitely getting into our flask here. And I have the balance right next to us ready to weigh our flask with the CO2. All right, I'll add another shot of HCl. All right, so I have added plenty of HCl to make lots of CO2, and I'm checking, yes, it's still a good connection here. So what I'm going to do now is I'm going to weigh it. All right, so I am confident that this is full of CO2 at this point, and so I'm going to disconnect. And then I'm going to put it into my balance, and I'm going to get the mass. 69.1950. 69.1950 grams. All right, and to make sure that it is completely full of CO2, you can hook it back up. Make sure the gas is still coming through, yes. And I'll let this go up. You can see that the CO2 is still being generated at a good rate. Maybe you can see that going up to the top. And then I let go and it comes down, and now the gas is free to come over into our flask here. All right, so I will let this go for another, well, minute or so, which it has been. And I'll check again, make sure that the mass is the same. Again, we want to make sure that it is full of CO2. All right, so now we have 69.2071, 2071, so it did go up. All right, so we will hook it up again. All right, it's still got CO2 going in there. All right, we'll let it go, add a little more HCl. Generating CO2 at a very large amount of volume of CO2. We'll let it go for another minute or so. We'll weigh it again. Whenever we get masses that are the same twice, then we know that it is completely full of CO2. That is 69.2177. All right, so we will continue adding the CO2. Pinch it again. Yep, it's going up. Not going up as fast as it was before, but it's still going up at a good rate. Our balance is now calibrating itself, so I'm going to let this go longer than I normally would for the balance to finish doing its calibration. Once we have our final number, I'm going to fill this with water. And again, I'm going to fill the inside. Wherever there is gas, I need it to be full of water to find the accurate volume. It is a 125 ml flask, but we want the volume that the air would have occupied and the volume of the CO2 that would have been occupied in this flask. So it is not going to be a volume of 125. It may be a little more, maybe a little less. It depends on what we get when we fill it with water and get the mass of our flask with water in it. All right, we're still generating CO2. I'll add one more shot of HCl. All right, our balance still has not zeroed out yet. We're waiting for the balance to zero out. Then I will weigh this again. Our CO2 is generating at a large clip again. As soon as our balance has calibrated and reached zero, I will weigh our flask. I think it's getting close. Not zeroed out yet. Okay. All right, but now we will definitely have plenty of CO2 generation going on, and we will most likely go with our next number that we get here. All right, it has set itself to 0. All right, so let's get this on our balance, get a mass. It is 69.2325, so it's still going up. So let's go again. I thought that would have been the same. It is still increasing. So 69.2325 is our mass at this point. All right, so, well, I thought it was our last shot of HCl. It is not. All right. Lots of CO2 being generated. All right, let's go ahead and weigh it again. And this is 69.2340. Still going up. We'll look it up again. All right. More HCl. Got our CO2 generator going. Yep. All right, let's try it again. See if it's still going up. All right, it is 0.2356, 0.2356, so 69.2356. All right, let's look it up one more time. All right, still going. That go for another minute. We'll get another mass and see where we're at. Get another mass here. Two, 3, 6, 0. All right, so it is not changing much at all. So we're going to go with 69.2360 grams as our mass of the flask filled with CO2. So 69.2360 grams. All right, so now we have to fill this with water. So wherever there would be CO2, we need there to be water there. And so to do this, I'm going to fill it with water. All right, so this is full of water. And then when I put this in, that's too much water. I'm going to need some towels to wipe the outside. CO2 doesn't stick to the outside. Water will stick to the outside. All right, so put this on tight. Get some paper towels. All right, now this is wet for one, and for two, it's going to have a pretty large mass. So I'm going to use my high capacity triple beam balance. Again, I have water that's sitting on top of this rubber stopper. I want to get rid of that water. I want to get rid of the water stuck to the side, stuck to the bottom. So the gas isn't on the outside, the gas is on the inside. All right, so I have the entire flask full, including the top glass rod is full of water, because that is where CO2 would be when we weighed our flask with our rubber stopper and the glass rod. All right, so now that I have wiped off the side, we're ready to get the mass filled with water. All right, so let's zero it. 200 plus 2. All right, 210. All right, so that's gonna pretty much do it. All right, so our mass of water in the flask, with the flask and the rubber stopper, is 210.68. 210.68 grams. And that is all the data you need to calculate the molar mass of CO2.